Well, hi everyone. Another year,
Hello.
another masterclass. We are here. We are back again. We hope you start 2022 with your right foot. Me and Pedro are here, pretty excited to start another of our masterclasses, the seventh one and the first of the year 2022. Today we are going to talk about how to avoid reflow and repaint. Pedro is going to be your host for today. We are going to talk a lot about this topic and the main topics that came by producing this presentation and talking about Reflow and Repaint. We are going to tell you how a browser renders on a page, the Reflow and Repaint part, what causes Reflow and Repaint, minimizing these, the tools that can help us, and we end up with our final conclusions. Okay, so Pedro, you can take this presentation from now on, and I hope everything is fine with you. I forgot to say this.
Yes, everything is fine with me. We are all healthy here. So, yeah. Okay, hello, everybody. Welcome to another session, as João said. So, let's talk a little about reflow and repaint. What is each one of these terms, and how to deal with this. So let me just start by this sentence that we probably doing doing some really stupid things in CSS that we don't know about. And this sentence was said like in 2009, but forgetting about the context where it was said, I would like to use this sentence to begin this masterclass because it really makes all the sense to what we are going to say here. And basically, if we think about the browsers and the web back in early 2000s and around that time. Basically, what the things that we were used to do in terms of front-end designs, not so much about getting data and dealing with logic. Okay, that's not the point of this masterclass. But regarding the front-end design that we made for our web pages, we were used to deal with mostly text and tables and forms and dealing with images because the internet was so slow, and sometimes show more complex graphics in the form of GIF files and all of that. So the time that we spent on improving the loading times back then, it has a lot to do it with the most of the time that we spent was dealing with the look and feel for a certain browser to be exactly the same that this in a different browser. Okay, the legacy between browsers, and that the experience delivered to the user was the same between the browsers, because back then most of us know that this was quite an headache to make sure that a couple of lines of code work the same way in one browser and then another one. The browsers were so different between them. So we were used to learn we use our to learn CSS and HTML and some JavaScript, mostly for these compliance subjects, and not so much about performance. Okay, and that led us to start doing things in a certain way that we know they will work. Okay, and we didn't have the need to understand if what we're doing was the best approach or the best solution. Okay, so what at a certain point in time, this starts changing. And for me, in my perspective, the three main reasons for this, for the change and for the states that we are today, the three main reasons are the modern browser, that the modern browsers that start appearing, the mobile area, the mobile devices that from one year to another starts to grow and grow, and the modern web that we know today. Okay, so the modern browsers start giving us the ability to inspect our codes, to understand that the code that we are doing really add a great impact on the final on the end user experience. Okay, and the mobile aspect of this changing was that since mobile devices, I mean phones and tablets and everything else, they start growing so fast and appearing devices with such different such different screen with different screen sizes and resolutions and all of that, and obviously we the time that we spend early with dealing with different browsers, now we have the needs to start using that time to deal with different mobile devices. Okay, and obviously the legacy also was introduced with all the mobile devices, and then the modern web. And basically by modern web, what I mean is teams teams of designers that didn't exist so far, they start appearing. For me, they make all the sense. I'm not saying that design teams shouldn't exist. By the contrary, but the thing is, they start creating more crazy UI stuff. Okay, they start imagining new animations and more types of interactions with the user. Okay, and we as front-end developers start having the needs to deal with all of this stuff. So obviously this is kind of a 45 minutes masterclass. I don't have all the time to go into detail about everything that we are going to talk. Okay, I just want to give you some highlights about some small things that maybe can help you debugging an issue that you may have with your JavaScript or with your CSS. Okay, I just want to give you some tools and some heads up about potential problems that may occur with the way that you are making your code. Okay, so for that, let me just start by spending a couple of minutes talking about how the browser renders a page. Okay, and again, without going into further details, there are a lot to say about this. But in short terms, let me just talk about the DOM and the HTML DOM. Okay, so the DOM is not much than an interface that defines the way that a browser can be able to fetch a document from a certain server and show that document in the page. Okay, and that interface also gives the browser the ability of changing and manipulating styles and structure of the document that he retrieves. So the DOM then is divided into three main areas. Okay, the XML DOM, the core DOM, and the HTML DOM. Okay, and I'm not going further with XML DOM and core DOM. I just want to talk about HTML DOM. That is basically what defines the way that we can interact with the elements on the page or with the nodes that are on the page. Okay, it basically defines methods for me to interact with elements and, for example, retrieve an attribute that the element have, or it gives me the ability to apply some events to an element, for instance, a button, a click event on a button. And it also defines all the properties that each element have. Okay, so here we can see that we have the document here at the top, and then we start having our DOM tree, starting with the HTML, and then we start drilling down the tree, and we can see that we have quite a lot of elements down the tree. All right, so now that we have a quick highlight about the DOM, we need to understand again very quickly all the steps that the browser will do to get a page ready for the end user. Okay, and the first thing is the browser will fetch the HTML file from a server, and the browser will interpret the HTML file and will create the DOM tree. Okay, after the DOM tree, it's time for the CSS, and again the browser retrieves the CSS file from the server, creates the SCSS OM, and the tree for the CSS OM will be created. So finally, after these two first steps, we can say that the browser is able to render the tree, all right, the DOM tree. The merge of the DOM tree with the CSS tree. So it renders the tree and then kicks in with Reflow and Repaint. Okay, and after the Reflow and the Repaint, this means that the browser is going to start placing the elements in the right place and give styles to each element. Only after this we can say that the page is ready. Okay, but then again, we are going to focus on Reflow and Repaint. So about these two concepts, basically the Reflow is the method that the browser will use to calculate the exact position of each element on the DOM tree. Okay, and it basically happens not just in the beginning, but every time that we request a change to the layout, and we are going to talk this in the next slides. All right, so and with that, let me just give you a small information about the Reflow actions. Okay, that is, while a Reflow is taking place, while the browser is running through a Reflow, the user cannot interact with the page. Okay, the page is completely blocked. Okay, this is a blocking operation. Okay, so this, as you are going to see, this is quite important to understand and to have in our minds, because let's say that you have a script in your website that is creating a lot of requests for the browser to reflow. Okay, so during that time, keep in your mind that the user will not be able to interact with the page, will not be able to click on a call to action button to finalize buying a product or scroll down the list of products. Okay, then we have the repaint, and basically it's, again, as Reflow, Repaint is the process that the browser will use to give the styles, all the styles, to all the elements in the DOM tree. Okay, things like defining the background color, the font size, all of that. Okay, and again, it happens every time the look and feel of an element changes. Okay, things like hiding an element or changing the background color or the font size of an element, okay, and even when we animate an element. Okay, so with that, you already understood that there are quite a lot of occurrences that will trigger repainting, the repaint and the reflow of a page. And that's what I want to share some scenarios where this happens. Okay, and for example, changing a CSS property, sorry, like changing the padding or the margin of an element, will cause a reflow, because, as you know, if, for example, if you change the margin of an element, it will probably force the elements that are around to change their position. Okay, if you have like 10 pixels margin and you change it to 20 pixels margin, the elements around that element that you are changing will be further away. So a reflow is requested, and probably a repaint is going to be requested also. For example, as I said, changing colors of elements will only trigger a repaint. Let's say you append or remove an element from the DOM tree, for example, using JavaScript, a reflow and a repaint will also occur. If you, in your script, you request some window dimensions, that will also trigger a reflow. Things like changing a property to display none, also reflow and repaint. The more intriguing one is that even if you resize the screen, reflow and repaints may occur. Okay, and even the scroll, and I'm going to show you in a couple of minutes, even scrolling on the page is going to trigger at least a repaint. Okay, and I want to talk about the last one, that is more than one cause, but it's when you use JavaScript, for example, to scroll the window or get some computed styles, like what is the number of pixels of from one element to the top of the page, those kind of styles that sometimes we need on our scripts. So about this, the thing is, modern browsers actually start to learn how to deal with the increasing number of this kind of requests, this kind of reflowing and repainting requests. So the guys that develop browsers created a system that is basically a queue of changes, and basically what this does is all the changes that are triggered to by a script, for example, are going to that queue, and the browser will manage that queue. Okay, so it's a smart way of dealing with the huge amount of requests that usually happens in a more complex UI. All right, so but the thing is, in one way, the browser started to learn how to minimize the impact of all the requests. Okay, but then again, we developers are quite good on breaking this kind of best practices. That's this kind of improvements in performance that the browser can do. So basically, in this example, what we are doing here is a simple line of JavaScript, and we are requesting from the browser the offset top of an element, and we are increasing 8 to the number that is retrieved. Okay, so but what happens here is, and again, this could have more impact in some scenarios and less impact on other scenarios. But the thing is, when we ask the browser this kind of information, the browser, because it's so well taught, the browser needs to knows that we want the most accurate value possible. So what happens is, if the queue of changes that the value that the browser have, he will flush all the queue. I mean, if there are 50 or 60 changes to be run through, the browser will, in that moment, will flush everything, meaning it will run through all the changes, okay? And only after these changes occur, the browser is able to retrieve to us the correct value. Okay, so imagine that scenarios where the browser is struggling with animations. Okay, so the queue of changes is piling up, and out of nowhere, you ask the browser for an offset top. So the browser, which that is already having a lot of effort to deal with the changes, needs to flush everything and run through all the changes almost at once, just to retrieve you a single value. Okay, so now you are starting to understand that sometimes knowing exactly what means a reflow and a repaint, and what triggers these reflow and repaint actions could mean. Okay, so sometimes, yeah, but the code that I'm doing is so simple, but it doesn't run quite well in older browsers or older devices. So it's important for us to understand this kind of stuff, because the problem could not be our CSS, okay, but the way that we are making in this case, our JavaScript code. Okay, so as you can see, the browser can help us dealing with reflows and repaints, but then again, it's also up to us know some tricks and some ways of avoiding excessive requests for a reflow, for example. And I'm going to talk about a couple of them in the next minutes. For example, always try to keep your DOM tree as small as possible. Okay, so maybe you don't need a lot of elements in a component that you are creating. Okay, maybe you just need 10 or 11 components instead of 20 components. Okay, so remember to try to create or to use less nodes in your tree as possible, because this means that if you request a repaint, for example, and if a repaint needs or a reflow needs to run through your component, it's better for the browser to go through 5 elements instead of going through 20 elements. Okay, it's less consuming for the CPU naturally, and also for the GPU in certain scenarios. Okay. Next, it's about having a clean CSS. Okay, so since repainting, we saw that, and we are going to see that it's also time-consuming and resource-consuming for the browser. So if you have less properties and less attributes in your CSS, this is also a good way of helping the browser deal with everything on the page. It needs to run through less stuff, so it will be faster to the CSS to be read. And naturally, one thing that even for me sometimes is difficult to it's easy to forget, it's to use excessive CSS selectors, okay? Because for the browser to process this is more difficult, okay? It's more difficult for the browsers to run through CSS selectors rather than go through regular classes and IDs and all of that. So avoiding changing CSS using JavaScript, for example, okay? And what I mean here is instead of calling multiple styles of a node, what we should do is it's best if we apply a class to an element and then make the changes that we need. Okay, sometimes this is not the solution. I know it will depend, but if we can, it's always better to apply a class rather than create JavaScript and use CSS style to apply the styles. Okay, and also this is also important. So if I go back, let's say we have this component here, and I want to change the styles that we have here at the bottom. Okay, it's better if we apply a class to this element instead of the wrapper, of the main element. Okay, because we are saying that the browser only needs to repaint this and not everything. Okay. Another cool thing that we can do is in some scenarios we may have the need to change a lot of elements on our tree. So usually for this we go in two different. We can go, well, there are more than two ways, but let me just talk about probably the most usual ones. Okay, so if I need to change a lot of elements in the DOM tree, I can go with cloning the element that I want to change, apply everything using JavaScript, and then replace the original node. Okay. Basically, what we are going to do here is almost just creating a reflow and a repaint. Okay. The other way is we can change the visibility of the nodes that we want to change using, for example, display none. This will trigger at least one repaint. Okay, and then we make everything. We make all our changes, and we restore the display. And with this, we are creating a second repaint. Okay, and if we I mean, for each repaint, we are also adding one reflow. So one reflow and one repaint when we hide the element, one reflow and one repaint when we restore the visibility of the element. Okay. So this, instead of, in this example, we are changing the background, the style, and we can change a lot of things here. So instead of requesting a lot of repaint actions, we will only trigger two. Okay, the computed styles, as we talked before, things like getting offset top or client height. This is quite difficult for the browser to deal with. The browser needs, the CPU and the browser need a lot of effort, because as we saw, as I explained to you, since the browser will retrieve the most accurate value, he needs to flush everything that he has in the queue and calculate the value and give it back to you. So the best practice here is, let's say you have a loop for cycle. So instead of in each cycle of the loop, request offset left or offset top, probably is best for you if you request this first and then run through the loop and change the values. So this way you will only request 1, 2, 3 in this scenario, instead of requesting hundreds of styles from the page. So avoiding inline styles, again, this is similar to what we talked before. So avoid having inline styles is also a best practices, not just in terms of front-end CSS best practices, but also it will influentiate the amount of the effort that the browser needs to do when dealing with changing 1, 2, 3, or 4, whatever styles of an element. Okay, so the best practice is always use classes or IDs if you need sometimes to give styles to the elements. Okay. One more thing that I would like to share with you is using absolute and fixed positions on your element. Sometimes it's is the best solution that we have on our side to make things this as smooth as possible. Okay, so because reflowing is the main reason that animations can get glitchy or slower, mostly on older devices. All right, if we avoid them, again, it's always best. Okay, so we can always use the GPU from the device to help on these kind of tasks, on animating something, but that's not just what we can do. Okay, and using absolute position or fixed position on our elements, on the elements that we are going to animate, sometimes we can do that, sometimes we cannot, but when we can, it's always best to use absolute. And I can give you a quick example. So, for example, if I want the user to click on an element, and that element, I want that element to expand and show more content, the best practice is, okay, I'm going to create a new element using JavaScript, a new element on the tree, on the DOM tree, using JavaScript, okay? That element will have the display attributes absolute or fixed, and then I'm going to animate the element to the right place until it's completely visible on the page. Okay, so this way I'm not interfering with any element that is already on the page. So the reflow that we are going to trigger is going to be less costly for the CPU to deal with, because I'm going to kick in with I don't need the browser to run through all the elements, all the nodes in the tree. So naturally, it's going to be faster, mostly on the older browsers. Just another thoughts about the smoothness of what we are animating on the screen. Think about this as not losing smoothness, but instead, sometimes if we want to, let's say we want to animate an element, we want an element to go from the top to the bottom of the screen, we can change 1 pixel at a time, and that's fine. But it's much more costly for the CPU than instead of moving 1 pixel at a time, for example, we move 3 pixels at a time. Okay, if our animation is set to last 200 milliseconds or something like that, probably this is not going to be visible. This jump of 3 or 4 pixels at a time will not be visible for the end user. Okay, and with this we are drastically reducing the number of repaints or reflows that the browser needs to perform. So some tools that can help us understanding our code and see what and help us dealing with the code that we are doing. Mostly, at least for me, I use browsers to as the main tool to see this kind of stuff happening. The Google Chrome Dev tools are very good, and also Firefox can deliver a great job on these. But also you have a couple of extensions for the browser. For example, the Lighthouse extension also can help you dealing in a certain way with this kind of questions of problems. So our focus here, what I'm going to demonstrate you next, is going to be the Google Inspector tools. Okay, so let me go to my browser. All right, and for those of you who usually see our masterclasses, they will immediately.
This looks quite familiar.
Yeah, they will remember this application that we presented a couple of masterclasses ago, and I want to use this just to give you to show you in the Google DevTools where you can inspect your code to see what is going on regarding layout changes and repaint changes. Okay, so if you enter the inspector tools of your page, you can go to, let me see, you can go here to performance, and when you get here, probably this will be empty. So what you want to do is to start a new recording, and what will happen here, is the browser will start recording and saving everything that is going to happen in your page, everything. Okay, so as you can see, I'm hitting recording, and now I'm hitting start shopping, and the page is going to start loading. Let me just stop this right here. Let me check one thing, because I think I'm limiting no throttling. Okay, let me go back again. Okay, so performance. Okay, and now hit and start. Okay, so we wait for the page to load and we hit stop. Okay. After we hit stop, we are going to be able to see what happens during this time frame that we record. Okay, we have here some previews of the page, so we can see more slowly what is happening here. The first images to load. We can see that since this is OutSystems, we can see the animations, all of that. And if you go down here, okay, just a second, performance, and okay, so here at the bottom, you can see a brief resume of all the tasks that were made by the browser while rendering this page. And the ones that are important for us for this masterclass are the ones that are saying rendering and painting. Okay, so we can see that all the render tasks that occurred during this time frame took more or less than 200 milliseconds and 57 milliseconds on repainting tasks. Okay, and if we go to event log, we have these two options here, rendering and painting. We can activate both of them, And for example, let me just show you the rendering first. If we look for layout, we can see that all we have here are all the layout requests, the layout changes requests that occur during the loading process. And the same you can see for painting. Okay, you have a lot of paint requests. Okay, most of them were applied to the document. Then we have composite layers, a lot of stuff that you can see here. And if we go back also to the rendering tasks, if we click on this, for example, we can see more these details. For example, this task that occur here, it also show me a warning saying that there was a forced reflow that potentially can cause a bottleneck here. Okay, so this kind of stuff, this kind of information is quite useful for us to know. Okay, because you know that I'm on a browser, so I have a lot of CPU power to process everything. But if this page, if I'm opening this page on an old Android phone, maybe this warning here starts making some sense. Okay, so again, you can reduce the time frame for you to see, so you can only so you can expect only when the time where the thing starts to show, and you can start see things here. Another cool thing that that you can do that can help you understand the flow. No, not this. Oh. Okay, so another. Come on, this is not what I want. Okay, I think this is it. So what we have here is basically this is just almost just for fun, but you can see a 3D module of your page. If you sometimes if you are struggling with the positioning of each element on the page, you can use this to try to debug. It's just for an example, but the cool thing is if you hit escape and for you to see the options like the console and all of that. If you go to rendering, and if you don't have this option here, you can go here to these three dots, hit more tools, and hit on rendering. Okay, so the rendering tab is going to be visible. The nice thing here is if you click on paint flashing, basically what this is going to show is all the every time an element is repainted, it's going to highlight for a brief second. Layout shift regions. This is also useful in not in this scenario, but in more complex pages, and this will show you the elements that will be moved when other elements came into place. And also you can try to take a look at the scrolling performance issues. Okay, this will show you the places where a scroll or an event handler may occur that can be causing the CPU to struggle and the browser to struggle while rendering this page. Okay, so if I refresh this page, what you will see is the elements appearing on the page, and each green box that you see here, it's a paint on the page. So for example, if we go to network and we force this to be slower for us to be easier to see, if we hit refresh again, we are going to see the page building itself, right? So more renders, okay? And if I scroll on the page, you will see also that we have other repaint actions, okay? And if I click the element to show the details of this product, okay, you can see that some of them are in a different color, okay, and those are those layout regions, those layout shifting regions that are occurring. Okay, I can do it again. Okay. Okay. Right. And for example, if I click this star here, you can see that the star is being repainted. Probably what is going on here is the browser is still repainting stuff. So that's why that's what's going on with all the flashing. Okay. So now I'm clicking, and only this area of the page is being repainted. Okay. So this is quite cool. And again, you can see the same for resizing your screen. If I resize my screen, you can see each part of the page is being repainted or reflowing. And even if I can also show you that even the focus and the blur on a simple input may cause a repaint. So if I blur or if I focus the input, you will see that this is going to be repainted by the browser. Okay. And then again, there are a lot to say, a lot to experiment here. We don't have a lot of time. My goal here was to share some thoughts on this, show you that you have tools, you have a way of understanding what is going on. Okay. So going back to our presentation. Okay. Sorry for the loading. All right. So final thoughts on what we said so far. Think of these as making web faster instead of silk and smooth. And don't get me wrong, I'm not saying that I like to see things running smoother on an application and have a beautiful UI and things like that. But what I'm saying here is pay attention to the performance of what you are doing. And the performance should be the number one priority. And I know that it isn't for most of the designers and the clients, because they sometimes they want to see everything shining and beautiful, and they forgot that users may be using their application in an older device. So by experience and personally, I believe that if we set our number one priority as the performance, as being the performance tasks, what we are saying is I'm avoiding that a user that arrives at my application is not going to see a bad interaction and a glitchy interaction, because that could be the frontier between the user closes our application and not being able to see a product or click on a button to buy that product, and opening our the other store that also sells the same product. So at the end of the day, bad performance naturally will mean less a worse interaction with the user, and we are going to lose users on our application, or we may be creating more stress to our users, and naturally nobody wants that. So that's what I'm meaning with this sentence. So personally, when I am experiencing an application, I prefer to have a quick application. So I prefer to do things as quick as possible instead of as pretty as possible. Okay. So with that, we are not going to show to have some question and answers today, but I think if you have any questions, you can type them on
the comment section.
Section.
Yeah, and we can answer you right away. So with that being said, Pedro, that was a great presentation, and those final thoughts, I think that you summed up what you have said on this presentation. And that's it. I would like to thank you all for being here with us. I will advise you, as always, to like, share, and subscribe this content and our YouTube channel, because we are planning on doing this content plenty more often. And now that we have adopted these kind of pre-recorded master classes, we are preparing them for you to have the better content and the better insights that we can share with you. So with that being said, have a great day or a great night if that's your case, and thank you all. Okay.
All right. Thank you, and stay safe. Bye bye.
Stay safe, everyone.
Bye bye.